So in this one we were looking at finding the area of some irregular shapes. And the first one was circle A. Now we can find the area of a circle without much issue, but it's a nice one to use because it gives the idea of understanding overestimate and underestimate and how precise and how approximate these are. So I know that if I'm looking at the area of the circle that the radius is 3. So I'm looking at pi r squared, which means that this is 9 pi square centimeters, and that's approximately 28 and 3/10 square centimeters. Now, that's what it is by finding it using the area of a circle. Now, say that I didn't know that, and I decided to use the idea of the underestimate, overestimate method, and I said to use this polygon tool. Now, sometimes trying to get it right near the edge because it's fixed to grid, you'll see, like I'll show you here, sometimes it doesn't want to click, and if it doesn't get exactly where you want, does something funny like shoots it off to the side, like in this one, just create a rectangle and then you can move the points. Like say I accidentally did it over here. Oops. Well, I'll create it. I know it's close. And what I can do here is I can just take this point E and just move it over. Not a big deal. These points are movable, but I can see that that only includes all the full squares that are on the inside. Now, I can count those blocks physically and see that there's 16 blocks in there. What I can also do is if I right click and then click Show Label, I'm going to get a hold of that label. Now that says Q1. That's the name of this square that I just created. But if I right click again and do settings, I don't want the name. I want the value. And what that shows me is that I have 16 squares in this square Q1. So there's 16 square centimeters for the area of that square. Now I'm going to do the same thing with my overestimate here. So you can see I'm going to go all the way to the point of where I can see it's touching the edge. It does not go over the edge, so I don't need to go any further than where I have. And I create that larger, in this case it's also a square around my circle, and I'm going to show the label. And again, let me move this label out of the way. I can see this square is called Q2. Again, I can go and I can change using the settings, change this to value, and I can see that's 36 square centimeters. So that means if I want to do my overestimate and my underestimate average, that I would do the underestimate plus the overestimate divided by 2. And this would give me 26 square centimeters. And you can see it's not exact. It's not the actual area of the circle, but it is relatively close based on the grid for which I was able to use to make my overestimate and underestimate. If I wanted to get it closer to the area, I'd have to use smaller squares for my grid. Now say that instead of it being, you see this last question asked, that I have, instead of a 1 centimeter by 1 centimeter square for each of the grids, it's 1/4 by 1/4. What that would mean, what I'd have to pay attention to, is that I have 26 squares, and I got to think about, well, what's the area of each square then? If it's 1/4 by 1/4, that means that I have 1/16 square centimeters for each square. So what I have to do here is take the 26 and divide it by 16. Now that would come then to an area of 1 and 625 thousandths square centimeters. So just by changing the size of the squares and what they'd be worth significantly impacts what the overall area is. So do pay attention to what is the size of the grid and what it tells you about the lengths or the area of each square on the grid. It's very, very important. All right, so now we're going to go and look at the irregular shape, and we're going to do the same thing here. Let me create a blank sheet here. Now here, I don't have the luxury of knowing that that's an actual shape, so I've got to use this approximation method. So I'm going to start with let's try again. I'm just going to start going around and trying to catch all the squares that are fully enclosed and have no black lines and don't fall outside my image. So I keep going around. If it has a black line, I don't include it. That's part of the underestimate aspect, is it can't be on the edge or outside. It can get close, but it just cannot be there. So the one that's the toughest to figure out is really after you go here. That one's kind of hard to tell. I'm not going to include it because I think it has a little bit, so I'm just going to go down. This one looks okay though. So, and then I'm going to go over and up. Now, that's a very funny looking shape, but here's the really nice thing if I'm using GeoGebra. I can count all those boxes if I want to get the number of squares, but what I can also do, again, show label, and then I can right click and go settings and pull open the value and see, oh, there's 31 squares there. So that's my underestimate. And what's nice, I didn't have to actually count all of them myself. I used the program to my advantage. Now the overestimate, again, I want to include every block that has any line. So I'm going to go all the way around it and count up every block. If there's any outline inside that square, it gets included. That's the difference. So underestimate, I don't want to include if it has outline. Overestimate, I want to include everything possible, inside and out. So I just keep going around. But it has to have some of the outline in it. So I come down, go over, come down again, go over, come all the way down to here. Even these look like they have a little bit, so I'm going to include them. And there I have, that's the area that has all the possible squares. So I'm going to show label. That's again a right click, show label, right click, settings, and I'm going to do the value here. And I have 82 square centimeters. So I know then that the area will equal the average. So 31 plus 82 over 2 is going to give me 56.5 square centimeters. Because I know that I was to assume each of those was 1 square centimeter block. Now, the last question there asks, what if the shape had been actually 1/4 by 1/4 centimeter blocks? Again, that means that I have an average of 56.5 squares, and I know that each square, because it's 1/4 by 1/4, that's 1/16, and then centimeter by centimeter gives me that centimeter squared, that I have 1/16 square centimeters for every square in the grid. So that square cancels, and that's how I know I'm left with the correct unit. And when I do 56.5 divided by 16, I would get that the area would have been 353,125 100 thousandths square centimeters. So By changing the size of the grids, it makes a huge difference as to what the area would have been. So pay attention again to what is the actual length of the squares.